Today is December 27th, 2022. This is my 172nd episode for C++ 17 2023 CUDA SQL OpenGL TBB Vulkan. This is the second episode for vector calculus. We will implement class vctr3d. We will use C++ functional programming technique to implement vctr3d or vector 3d class. This programming technique is new to me too. I tried using C++ 17 before, but was not very successful. With the introduction of C++ 20 concepts, now C++ functional programming is at least doable. I assume you have installed C++ library extensions. You can download the source code by using this link. Also, you have to watch these videos listed here to set up developers' tools on your machine properly. Without further ado, let's get started. Open up Visual Studio Code, CPP 17 2023 parallel. Select empty folder, click this button, 172 vctr3d. Click this button, cpg vector hpp. Select this folder, click this button, test.cpp, hit enter. Close this file, Ctrl V. I will arrange side by side. Author Thomas Kim. First edit December 27, 2022. If not df, cpg vector hpp, and if end of file cpg vector hpp. Define cpg vector hpp. Include cpg numerical analysis hpp. Namespace cpg end of namespace cpg. Namespace numerical analysis end of namespace numerical analysis. Namespace cpt cpg types. Now here include cpg vector hpp. Void test declaration. Int main, copy, paste it here. Now template. Type name, element type 1, type name, element type 2, type name, element type 3. Class vctr3d. This is primary template, which determines the template parameter count and category. So this is our primary class template. We use 3 template parameter. Now template, type name, element type, class vctr3d. this is specialization. This specialization requires 3 template arguments. Element type 1, element type 2, element type 3. These are called template parameter. In the angle bracket, we have to provide 3 type arguments. Element type 1, element type 2, element type 3. So this is specialization. Don't miss semicolon here. Now we give constraint std floating point. Element type should be floating point. Now template type name, element type 1, type name, element type 2, type name, element type 3. Class, this class name here, this is specialization. I will say fun x, fun y, fun z. So we have to provide 1, 2, 3 template argument. Fun x, fun y, fun z, semicolon. Now we put constraint requires. We use parentheses std invocable fun x float or std invocable double or copy this paste fun y, copy paste fun z. Now remove this. So our requirement is that at least one function here should be invocable. It means at least one type in this template parameter should be invocable with float or double. At least one template argument specified here should be invocable. Here I will use public element type mx, my, mg. Now here public we say fun x, I would say f x, fun y, f y, fun z, f z. Now we create constructor here. Public, we will declare default constructor no except default. This is our default constructor. Then element type x, we initialize mx with x, then my default value, mz default value. This is our constructor. Copy this, paste. It can be explicit, also no except. Now element type x, element type y, it should be no except. Now copy, paste. This is G, so it should be G. We created constructor 1, 2, 3, 4. 4 constructors. Now here we create constructor like this. Fun x fx, fun y fy, fun z fz. We initialize fx fx, or we can say std move. Because this is copy semantic, we copied function or functor or lambda, so we can move to fx. fy std move fy, then fz std move fz. So this is our constructor. Now here we declare an instance of this vector like this using namespace cna cpg numerical analysis. We don't need using namespace cpt cpg types. CNA, in this namespace, we have vctr3d. We pass double. This is very boring. A. We are testing default constructor. This constructor. Open up CD 172 vctr3d clang std c++20 test.cpp ltbb12 oc.exe. Hit enter. I misspelled here. No except. We try again. CLSC. Okay, it built successfully. I will make it shorter. Now CNA vctr3d b, we provide 1.0. It will not work. Let's try it anyway. No, it doesn't. No viable constructor or deduction guide for deduction of template argument vctr3d. We can create deduction guide. Now copy this constructor. Copy, paste it here. Template. It should be std floating point element type. We can remove explicit. Then we use arrow. Then we specify element type. Don't miss semicolon. This is so-called explicit template argument deduction guide. Or somebody says class template argument deduction guide, or CTAD. With this, it should work. We build again. Okay, it built successfully. Now let's try another one. C 3.0. It will not work. If we try again, it does not work. We need another deduction guide. Paste it here. Copy. Paste. Now arrow. Copy this. Paste it here. You have to understand how I make deduction guide. With this should be function properly. See, I will create another. Copy, paste. Now element type G. Of course, we can remove X, X, Y, X, Y, Y. I will create. Copy these. Paste it here. Now copy this constructor. Then paste it here. Make arrow. Then paste. Fun X. Fun Y. Fun Z. Don't miss semicolon. Of course, we can remove fx, fy, fz. So I made deduction guide. Now here we can try the 4.5. We create CNA, vctr3d. Now this is E, D, F. So we are creating lambda, oro, T, return, SED, cosine T. This is lambda. Then 2.5, 6.7. So this is F, X, this is F, Y, this is F, Z. Here, as long as one of Fx, Fy, Fz is invocable or callable, then this construction is valid. Now, build once again. CLSC, clang, build successfully. Of course, GNU also should build. With Microsoft compiler, CD 172, vctr3d, CLEHSC, SDD, C++20, test.cpp, fe, m.exe. Hit enter. Microsoft compiler should also work. ICPX, SED, C++20, fno, SQL, test.cpp, oi.exe. Hit enter. Microsoft compiler built and runs. CLSI, Intel compiler also works. I will give all the details how to implement 3D vector using C++ functional programming technique.